Hope my screen is visible. All right. So, uh, as of now, we had discussed about various methodology involved in light curve plotting and analysis. And the first session, that was last to last session, we had discussed about target selection and observational setup, where we discussed about various factors we need to take care of while selecting our target, selecting the location, and building your setup. Regarding your camera, your telescope, your lighting, your temperature of the camera, the lens quality, all of that was discussed. Right. Now, in the previous session, we had discussed about data acquisition and transit modeling and data analysis, wherein data acquisition was discussed in detail. We had discussion about variable star plotting using AFSO and image procurement and image storage. Then we went into transit modeling and data analysis, wherein we primarily started discussing about transit modeling. And for transit modeling, also we had three major steps to be followed, wherein which included stacking of images, processing images, and finally the data analysis. So we started with stacking images, wherein we discussed about what stacking images means and how it can probably enhance the quality or how it can clarify the details in any image that you take. Right. So we looked at how to do that or how to execute it in a launch binder called Jupyter Lab Notebook. And yeah, then we looked at a few example images wherein we looked at various versions of the same capture when it involved stacking with various filters like visual or direct uh, or infrared filters. And we also looked at a comparison of different images, wherein it is raw image and the direct stacked image, which showed us that there is a clear clarity difference as well as a detailing difference when zoomed in. Then we tried to add the filters without, like, by blocking the other wavelength. So we got colored images. This is before the monochromatic stacking. So the reduced images when added with filter is what you see here. And those, when you superimpose together, is what you get, a final image like this. Right. So this image or the colors of this image widely helps us to identify the various composition, the various kind of gases involved, or the various kind of densities, temperatures, etc., due to the color coordination of this image. Then we moved into processing images, wherein we discussed about astrometric calibration as well as photometric calibration. So astrometric calibration will help us detect the stars in a certain observation. And these stars will be matched further into the reference catalogs that we receive. Now, when I discuss about AFSO and when I show you the user interface, I'll be showing you how to obtain the reference catalog from there as well, and also how to see the stars that you can, the comparison stars and various factors about it, how to get a how to plot a chart, that is your AVSO chart, or also how to get your photometric chart. So both of these will be available on that same platform. So we'll be looking at that when I share screen with you. If time permits, we'll do it at the end of this session. Okay, we still don't have a great strength. So I think it's better we keep a separate session for that so that we can explain all the features involved as well, because there could be a number of features in that will require proper explanation. So We'll see on Monday. Uh, we'll do the APSO project on Monday. So all of you, when you attend on Monday, try to be on a system, on a laptop preferably, so that you can simultaneously, log into the platform and try to check out what's up there. So if you would like to, you can check it out later after the session, but it would be easier if you can see what you're trying to understand as well. So yeah, that is about astrometric calibration. Now we tried to see what difference in both these images would be, and these two images, as we can see, it is astrometrically calibrated in visual filter and infrared filters, and this is because we can see way more stars or way more detailing in the second image, that is the infrared image. And this is happening primarily because most of the stars in the night sky during the capture are deflected by infrared filter compared to the visual filter. Now that is primarily because of the colors, because visual filter has a blue color and infrared has a red color blockage. So these two colors are, when you look at the wavelength also, one has the least and one has the most, right? So in that case, infrared filter would tend to deflect the stars a lot more compared to the blue filter. So the photometric calibration will help us, like this is astrometric calibration. So post this, when you do a photometric calibration, it will help us a lot more to match up the brightness of the picture with the actual stars that you can observe on that picture. Yeah. So last session, I believe we stopped it in this slide. So give you a gist about this once again. So these two charts are of photometric calibration of, here we have taken M42 Orion Nebula as the example. So for photometric calibration, we have taken the first image that you see on the left is visual filtered or blue filtered. The second image is infrared filters or IP filtered, right? So in both these charts, if you look, you can see that the top graphs are of uncalibrated magnitude. Uh, so that is before the calibration has happened or before the photometric calibration has happened, and the bottom ones are after the calibration has happened. Now, few things you can observe from these are, let's say, here, if you take the uncalibrated magnitude, for example, of the visual filter, so there are some fainter objects on the right of the plot that is of larger magnitude, right? So the magnitude is keeping on increasing from on the x-axis. So as you go to the right of the graph, you see that there are more scattered, more fainter objects on the right side. Fainter as in the magnitude is increasing. So it is, the brightness is sort of decreasing. So the fainter objects on the right of the plot are of larger magnitude, and the brighter objects on the left of the plot is more of a smaller magnitude. Now, among these scattering of objects, or these scattering of observations rather, you see there is a sort of a blue line that is giving you a mean, or an average of all the rough values, right? It is giving you a mean value of both the kind of the larger magnitude observations and the lesser magnitude observations. Now, for example, let's say you take stars of 10 magnitudes, okay? And these, like 10 different magnitudes, like let's say you take one star of 15 magnitude, one star of 12 magnitude, one star of 16 magnitude. So you just randomly choose 10 different stars of 10 different magnitude, okay? Now this these 10 stars, let's say it's either having a point 0.8 offset, or it could have a 0 offset, it could have a point 0.2 offset. So with all these as a mean we are putting, it is having an error average of 0.4 offset, right? This is the error average. Now this offset that you see will be corrected by the blue line that you see here. Okay. Now this the mean line that you're seeing is just an error average that is being set off on an what do you say, on an ideal note. But in fact, this is being corrected by the standards of the blue line that you see on top. Okay. Now, this blue line will help us calibrate the magnitude of the star and magnitude of the star against the difference in the reference catalog. So, in the reference catalog that you get from certain sources, those will have some sort of what do you say, variations, and that variations plus the mean that you see here will be giving you some sort of accuracy with the blue line. Right. Now, now you see there is a lot of scattering that is seen in the in all of these graphs, right? All of these graphs have a lot of scattering of observations. So these scattering of observations is basically the uncertainty in the measurement of brightness. So it has a sort of what do you say? The measurement of brightness is determined by a lot of other factors. So these factors could be fluctuating. So because of that, there is a lot of uncertainty when it comes to the brightness, even in the magnitude. So magnitude, they can't just point out to one single spot and say this is the magnitude. So it will be varying, it will be fluctuating based on a lot of different factors. So the scattering that you see is primarily because of the uncertainty of that factor. Now it is very important that we make sure, or we cross check, that the software has done some accuracy, or has got accurately been calibrated when it comes to photometric calibration. Right? So once it is calibrated, this is what we get. Right? This is the image we get after calibration, or this is the graph we get after calibration. So, in order to do this, we need to make sure that the plotting of the faintest and the brightest stars, right? The faintest stars would be somewhere on the right, as the magnitude increases, and the brightest star would be somewhere on the left as the magnitude decreases. Right. So, we need to make sure that the software has done a good job in calibrating it by checking certain factors here. Like the factors could be so the faintest and the brightest stars can be accurately checked if all the red stars that you see, okay, so red stars are basically that has been filtered out based on the wavelength, and all of these red stars or red observations, the scattered observations that you see, are lining up in a systematic manner along the y-axis, right? In the side of the y-axis, it is almost systematically lining up to a point. And to ensure this, a brighter star, like like let's say we have chosen a brighter star. That is, when I say brighter star, you should think that this is of a minimum value of magnitude. And let's say for this situation, okay, for this particular star that we are observing, we have taken a comparison star which is of the most closest brightest star it has,
ಇದು
and that
ಗಾಡಿ
brightest
ಎರಡು
star has
ಎರಡು
been
ಗಾಡಿ
marked
ಅಂತ
here
ನಿಭಾಯಿಸ್ತು
on a yellow
ಇನ್ನೊಂದು
line.
ಹಿಂಗ್ ಬರ್ತೀವಿ
Okay,
ಮತ್ತೆ ಎಂಟ್ರಿ
so the
ಮಾಡ್ತೀವಿ
brightest star
ಓಕೆನಾ
closer to
ಇದು ಗಾಡಿ ಸುಮ್ಮನೆ
our
ಜಿ ಎಸ್
observation
ಟಿ ನೋಡ್ಕೊಂಡು
is
ಬಾಳ
used
ಬರೋದು
here,
ಗಾಡಿ
and it is
ಗಾಡಿಗೆ
marked
ओके
as
ಸುಮ್ಮನೆ
of
ಗಾಡಿ
this yellow
ಬರೋದು
line.
ಪೂರಾ
Now
ಡಾಕ್ಯುಮೆಂಟ್ ಎಲ್ಲ
this
ಅಲ್ಲೇ ಐತಿ
yellow line is
ಸರಿ
अभी एंट्री करना है
placed here
ಇದು ಏನ್
so
ಬರ್ತಿದೆ
that you
ಓ
can
ಗಾಡಿ ಹಿಂಗ ಇನ್ನೊಂದು ಗಾಡಿ
force
ಆತ
the
ಓ ಗಾಡಿ
entire graph to be
ಇನ್ನೊಂದು ಗಾಡಿ
more
ನಿಭಾಯಿಸ್ತದ
more
ಇದು ಮೇನ್
spread across towards
ಹಿಂಗೆ
the left. Now this is just, the yellow line is more like a
गाड़ी आया इस
zoom
पे
in factor. Okay, so if not,
उठा एंट्री
these
कोड
magnitude scale is so tiny that when you look at it from like on a bigger scale, what happens is all of these dots will probably align as a straight line, will be one on top of the other in different ways, and that will sort of give you, I mean, lack a distinction for you to understand. For that reason, you try to put a brighter star as the yellow line towards the left of the graph, so that you can push all the other scattering of the observation towards the left, so that you can get a more clarified, more spread out, more scattered image. So you can check and you can understand the scatter of observations based on the magnitude as well as the offset. So this is one of the major ideas we have for photometric calibration. And also, it is very important that we understand that the minimum and maximum values of of the offset, like minimum and maximum values of the observations, that is whatever is scattered here, is readjusted in such a way that your offsets are also equal. Or it is,
খাবার আছে
if there is an offset of
খাবার আছে
plus
দুপুরের খাবার আর
0.2, then it
এই বেলার
also
খাবার
has to
আছে
be
ডাল
a
আর বেগুন নিয়ে নেবো
minus. That is how you write error averages, right? It has to be plus or minus 0.2 or plus or minus 0.4. Wherein the other case, we do not have a minus because we don't know to that point. It's just uncalibrated, and it's just scattered, and that is sort of like the mean, right? Now, from that mean, we are trying to derive it in such a way that the offset is taken to be plus or minus of zero point 0.2, plus or minus of zero point 0.4, which is why we'll be getting a sort of observation scatter in such a way that it is almost symmetric, along the x-axis. So this is the whole idea of photometric calibration. I'm sure the idea would be slightly, what do you say, confusing or not very easy to grasp it in on the first go. But as I mentioned, there are a lot of opportunities for you to go do your, like projects on your own without actually going to an observatory, or so you have platforms online wherein you can request for um, some observations. They'll send you the observations, and once you receive this observation, you can utilize some tools to do your own data analysis. So that will give you a much better idea about various calibrations and how to ensure your calibrations are right, etc. Right. So this is the gist of what these calibrations are. Um, okay. So this was about transit modeling, where we discussed about stacking images and processing images. Now we are coming to the data analysis part of it. Okay, so we have a few data analysis methods where we try to achieve some accurate light curve plotting. And this light curve plotting is taken purely based on what information you have processed before this. Right, so there is no additional information or additional data that you have. You just have whatever data that you've processed until then. So you have to make sure like you have to make very sure, you have to be extremely sure that whatever you've processed up till now is accurate to the point. Even like for example, the photometric calibration that I showed you in the previous slide, this is a software done calibration, but there could be some scale differences, some so I told you, a lot of these are trial and error methods wherein you put a few values, see how it turns out, see if that is the kind of result you want, and then you put another value. So the trial and error has to, it'll take you a while to keep iterating through different values and finally coming to the value, deciding on one value, and then going forward with that data. So yes, light curve plotting is the final step of it, and analysis comes after that, yes. But light curve plotting is the result of all that you've done till now. Right. So for the data
মোবাইল
analysis
নাম্বার
methods, we
879258
have different
9414. Please
softwares. We
verify
have a lot of
email
different kinds of
9648.
softwares that will support various actions, gives you different kinds of features. But primarily, I have worked on HOPS, that is Holloman photometric software, and Munivin. Then we have some called CDM. We have Star CCD Plus. Um, yeah, so we have a few like that. Now, for my projects, I mostly utilize Hops and Munivin because they are very user friendly, and plus these are directly under the European Space Agency. So uh, that was what was supported back when I started working in the Europe. So yeah, so Hops and Munivin is a good place to start your data analysis on astrometric data analysis, and slowly you can start exploring Star CCM Plus or CDM, and so CDM gives you based telescope.
व्हीकल का भी देना उनको व्हीकल का भी वो ना नहीं वो ना कौन तीन को सिर्फ डालना नहीं दो सील कहाँ डाल दिया अंदर डाल दिया क्या वो सील उधर कहाँ डाला गेट में उधर गेट है ना ये नहीं देता वो दोनों को डाल देता देखो तो व्हीकल का पे है हाँ इधर ये व्हीकल का पे है ये कस्टमर का पे है कस्टमर कॉपी है ये मेरा लेता कस्टमर लेता है इसका अंदर सील कहाँ डाला वही पूछ रहे हैं अंदर वही पूछ रहे हैं इसको सील बोलते हैं उधर डालिए वही आपको पूछ रहे हैं कि कहाँ डाला जल्दी ढूंढने के लिए मालूम नहीं है मैं दिख नहीं है तो जल्दी हो जाता है ना व्हीकल का बिल नहीं दे वही बात है मैं ढूंढ लिया आप खड़े रहिए मैं आपको देता हूँ उसमें है क्या देखिए नहीं नहीं इसमें छोड़ दो भैया ठीक इसमें डाल दिए ना हाँ डाल दिया डालना पड़ेगा ओपन करके लाइए वो दीजिए हाँ मोबाइल नंबर 994538 722 662 गाड़ी नंबर A41 4386 একটাই গেট এটাও তোমার হ্যাঁ এটা আমার হাতের লোক দুটো ধন্যবাদ
তুমি খেয়ে নিয়েছো না খাবে? খাওয়া হয়ে গেছে তোমার না খাবে?
রুটি নিয়ে এসছি না, তেলে গরম করে দিয়ে এসছি, সকালে গিয়ে গরম করে নিয়ে এসছি, দিয়ে প্যাকেটে ঢুকিয়ে দিই। আর তরকারি আজকে ডিমের ঝোল করেছিল।
গিয়ে খেয়ে
তরকারি
নেবে।
নেবে নাকি? আমার কাছে
ওখানে
আছে।
ওখানে আছে তরকারি, এটা ওটা সব আছে, যেটা লাগবে নিয়ে নেবে।
আছে দেখলাম, ভালো দিনে দিয়ে গেছে, রুটি আছে।
যেটা তোমার মনে হবে নিয়ে নেবে।
কি নেবো তরকারি করে, উপর থেকে কোনো ইয়ে পাচ্ছি না। আর এদের যে চামচের কথা ভাবলে দুঃখ লাগে।
আমার ব্যাগে এখানে চামচ আছে, নেবে নিয়ে যাবে, নিয়ে নেবে।
চামচ তো প্রথম থেকে ইউজ হচ্ছে না সেই চামচটা, আচ্ছা লাভ আর কি, সেটা একই ব্যাপার হলো। কিরকম খাচ্ছি এরকম আমি বুঝতে পারছি না, কমন সেন্স একটা নেই। তার থেকে ভালো এদের রাস্তায় খাবি না, ঝামেলাতে একটু ঝাঁটিয়ে দিল, রাস্তায় বসে বললো
চলে যাচ্ছে,
হ্যাঁ,
এরকম করে চলে যাচ্ছে।
অভ্যাস হয়ে গেছে এদের এরকম ছেড়ে থেকে। আমাদের অভ্যাস নেই না, মেন কথা হচ্ছে সেটা, এই জন্য আমাদের কিন্তু বোধ হয়
এটাই।
এদের শুধু পয়সা নিয়ে কথা, আদার্স আর কিছু করবে না। না রান্না ভালোভাবে রান্না করতে হবে, না কিছু, না ব্যবহার এদের ভালো। মশলা বেশি দিয়ে দিয়ে দিলে রান্না হয়ে গেল। আজকে কি একটা ছিল মেয়েদের, দেখছি এখানটা আমাদের আমাদের কোনো পতাকা আছে, মানে রাজ্যের কোনো পতাকা আছে নেই, আমাদের একটাই হচ্ছে ইন্ডিয়ান, মানে ভারতের পতাকা, তাই তো? এদের এক্সট্রা পতাকা আছে মানে স্টেটের। আমার রুমের সাইডে, মানে বিল্ডিং এর সাইডে আমরা যেখানে থাকি, দু তিনটা বিল্ডিং, ভারতের পতাকা এখনো লাগানো আছে, তার অস্তিত্ব অবস্থা খারাপ হয়ে গেছে। আর সেই বিল্ডিং এ কে কে থাকে শোনো, এইচআর থাকে, ইয়ে থাকে, কম বেশি শিক্ষিত মানুষ থাকে, তাহলে সেইখানে প্রতিবাদ করার কেউ নেই। কি কি করে করে বুঝতেই পারি না।
মাথা খারাপ,
হ্যাঁ,
মাথা হয় না।
হ্যাঁ, দেশের প্রতি না শ্রদ্ধা না ভালোবাসা। এই যে কোম্পানি এত টাকা কামাচ্ছে লাখ লাখ কোটি কোটি, দেশ না থাকলে তোরা বাড়া কোথায় থাকবি? এক্ষুনি এসে যদি আক্রমণ করে দেয়, তোরা বাড়া কোম্পানি নিয়ে ধুয়ে জল খাবি না কি করবি তখন? তাই কি না?
এখন কিছু ভাবছে না কেউ, সবাই ব্যস্ত।
না, যে যার মধ্যে সেটা আছে। খাওয়া নিয়ে কথা না, অনেকজন আছে যে ভাবে বলতে কি, দেশকে অসম্মান করা মানে কি সবাইকে অসম্মান করা, তাই তো?
এখন আর মাথা নিও না, ওসব কাজ করে যাও। সবাই ব্যস্ত কাজে, ওই জন্য আর কেউ তো মাথা নেই। ক্লাস হচ্ছে।
এটা নাকি এটা কত লিখেছো? ডবল সেভেন ডবল সিক্স
ডবল সিক্স
ডবল সিক্স
দেখি আর একবার।
ডবল নাইন ফোর
ডবল
এইট ডবল
হ্যাঁ
সিক্স
ডবল সিক্স।
ডবল সিক্স টু।
হুম
বেশি আছে নাকি? বেশি নাই না?
কিছু বলছো?
দেখো
हेलो हाँ ब्रो नंबर हाँ ठीक है बोलो 7381 7381 7381 बाद में 7381 बाद में 7358 नेक्स्ट 6 6 6 111 6 111 बाद में 21 हाँ ठीक है 737358 ठीक है ठीक है
Madam, I have no system. What name, madam? Madam, name. Can you say again? I will check in mobile.
তোমার নামটা কি? তোমার নামটা? অমল কুমার। অমল কুমার কি? দাস। ইয়ে কোথায় গো? হ্যাঁ, ওয়েস্ট বেঙ্গল না? ওয়েস্ট বেঙ্গল না, ওয়েস্ট বেঙ্গল থেকে আরো একদিন লাগে আমাদের এখানে। জায়গাটা নাম কি? আমাদের হাইলাকান্দি ডিস্ট্রিক্ট শুনেছো? হাইলাকান্দি ডিস্ট্রিক্ট শিলচর শুনেছো? শিলচর কলকাতা থেকে এখন তো ডাইরেক্ট আমাদের কলকাতা থেকে আমাদের এখানে ডাইরেক্ট ট্রেন যায় না। এটা তো বাংলা না অন্য ভাষা? বাংলাই আমাদের বাংলা। আমরা এখানে কাঁচা বাংলা, এখানে কলকাতাতে শুদ্ধ বাংলা। ওটাই তো আমাদের এখানে কাঁচা বাংলা। স্টেট তো একই তো, আমাদের একই স্টেট তো। হ্যাঁ, ওয়েস্ট বেঙ্গল তো। আমরা আসাম। আসাম না?
Sorry, madam.
আসাম না ওটা। আসামে বিজেপি।
No, I'm searching the website.
তাহলে উন্নতি হবে। আসামে বিজেপি।
Yes, ma'am.
কলকাতাতে আমার তো দুর্গার চলছে না। কৃষির জন্য কৃষি পিছনে লেগে আছে। ইলেকশনের সময় হলে ও কি করে, ও খারাপ হয়ে যায়, ও বসতে পারে না, আসতে পারে না। শুধু হিন্দু মুসলিম করে পুরা কৃষিটা কি করবে পুরা এখানে বাড়ছে। তো দোকানে কলকাতা রেট করেছে, এখন সব বাড়ছে। এসআইআর চালু করছে না, সবাই বাড়ছে হবে। ভারতীয় মুসলিমদের ইয়ে করছে না, কৃষির জন্য যাওয়া হচ্ছে। কৃষি আর পেশা।
কি বলছো?
মুসলিমরা হিন্দু, দেখি কি মনে হয় মুসলিমরা হিন্দু।
হিন্দু মুসলিম থাকে, পাশে থাকতে থাকতে এরকম দেখতে হয়ে গেছে।
পাশে থাকতে কি আবার কেমন কথা, তোমার কোনো লজিক পেলাম না আমার কথা।
তুমি দেখবে ওটা হয়।
বডি ল্যাঙ্গুয়েজ ঠিক আছে, ওটা বুঝলাম, কিন্তু আমি মুখের ফেসের কথা বলছি। একটু সকাল থেকে শুয়ে গেছে এসে, এরাই ডিউটি হচ্ছে। হ্যাঁ, এরাই ডিউটি হচ্ছে। হায়দ্রাবাদ শহরটা কেমন ঘুরেছ?
জানি না, পরে দেখছি।
আচ্ছা, ব্যস্ত আছো? ক্লাস চলছে? চালাও 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 বন্ধু চালাও রে, কাজ নেই তো পালাও রে। ইমেল পাঠিয়েছে।
Okay, madam. Madam, website is opening, but other features have to explore. See on details. Yes, madam. Yes, madam. Yes, madam. Yes, madam. No, as of now, no question, madam. Uh, we have to think. Okay, madam.
आउट ये क्या है? आउट आउट करना ना, वो आपका है, इसमें भी कुछ करना चाहिए क्या? इसमें कास्टमर है, निकल का दोनों। हाँ, ये तो कास्टमर का हो गया, नीचे वाला विकल्प है।
नोट कर रहे
हाँ
हाँ